Are you nervous about nailing your Java interview? Don't worry, we've got your back. Hey everyone, welcome to our Java interview prep series where we take you from zero to hero. Whether you're aiming for your first job or gearing up for advanced level interviews, we've got everything you need covered. We'll start from the basics and go all the way to advanced concepts, making sure you're prepped and confident. And if you're feeling a bit shaky on the fundamentals, don't sweat it. Check out my 50 Days of Java series linked in the description. You can binge the combined video or take it day by day with the playlist. So without further ado, let's dive into Java interview prep and set you on the path to your dream job. Hit that like button and subscribe to stay updated. Let's get started. Day 1 is all about a fundamental question. What are the main differences between JDK, JRE, and JVM? This is a must-know for any Java developer. So what's the deal with JDK, JRE, and JVM? Let's break it down. Think of JVM as the engine that runs your Java code. It translates Java bytecode into machine code, making sure your Java application runs smoothly on any platform. Next, the JRE is what you need to run Java programs. It includes the JVM and all the libraries your Java app needs at runtime. And finally, the JDK. This is the complete package for Java developers. It includes the JRE, JVM, and tools like the compiler, Javac, to write and compile Java programs. Got it? If you found this helpful, hit the like button, and don't forget to subscribe for more interview questions coming your way. Day 2 is tomorrow. See you there.
What's up, future coding legends? Let's unravel the magic of Java OOP. Object-oriented programming, or OOP, is like creating a miniature world inside your code, where everything is an object. Java, being an OOP language, uses this concept to keep your code neat, reusable, and easy to manage. We have 4 core concepts to cover. Encapsulation. Think of it as a protective shell around your data. It wraps variables and methods into a single unit, usually a class. Inheritance. Imagine borrowing traits from your parents. In Java, a child class inherits properties and behaviors from a parent class. Polymorphism. Like a chameleon, polymorphism lets a method adapt based on the object calling it. Abstraction. It's like driving a car without knowing the mechanics. Abstraction hides complex details, showing only what's necessary. Master these, and you'll be well on your way to writing efficient, clean Java code. Keep coding, and see you in the next video.
This is why you need to know method overloading and overriding for your Java interview. Let's tackle this common interview question. What's the difference between method overloading and method overriding in Java? Method overloading happens when you have multiple methods with the same name but different parameters in the same class. It's a way to perform different tasks based on argument types or number of arguments. It's resolved at compile time. On the other hand, method overriding is when a subclass provides its own implementation for a method already defined in the parent class. This is a runtime concept used for polymorphism to ensure the correct method is called based on the object's type. To sum it up, overloading is compile time, allowing multiple methods with different parameters. Overriding is runtime, where a subclass modifies the behavior of a parent method. Mastering these differences is key for acing your Java interview. Good luck.
In Java interviews, the static keyword is a frequently asked topic. Let's break it down. The static keyword is primarily used for memory management. It makes a variable or method belong to the class rather than any specific instance. This means a static member is shared among all objects of the class. Static methods can be called without creating an object of the class, while static variables retain their values across all objects. This is commonly used for constants or utility methods. A static block is used to initialize static variables. It runs once when the class is loaded into memory, even before the main method is executed. Understanding how and when to use the static keyword is key for managing memory and improving efficiency in Java. Good luck with your interview.
In Java, understanding the difference between double equals and equals is essential for any interview. Let's break it down. The double equals operator compares references or memory addresses, not actual content. It checks if 2 variables point to the same object in memory. The equals method compares the actual content of objects. It's used to check if 2 objects have the same value, not whether they are the same instance. For example, when comparing strings, double equals checks if they are the same object in memory, while equals checks if their content is the same. In summary, double equals compares references and equals compares values. Knowing when to use each is a common interview topic, so make sure you get this right. Good luck.
Today we'll explain the final keyword in Java, a topic that often comes up in interviews. The final keyword in Java is used to impose restrictions on variables, methods, and classes. Once a value, method, or class is declared as final, it can't be changed. A final variable becomes a constant. Once it's assigned, it can't be changed later. For example, when you declare a final variable for a constant value, it can't be reassigned. A final method cannot be overridden by subclasses. This is useful when you want to prevent method modification in child classes. A final class can't be subclassed or inherited. This ensures the class's implementation stays intact and prevents modification. In short, the final keyword restricts changes to variables, methods, and classes. Mastering these restrictions can help you in your Java interviews. Good luck! If you don't like cramming but still want to ace your Java interview, then stick around for this quick guide on inheritance. Inheritance is a core concept in object-oriented programming, and it's one of the most common topics in Java interviews. Let's break it down. Inheritance allows one class, called a subclass, to inherit fields and methods from another class, known as the superclass. It helps to create a natural hierarchy between classes, promoting code reuse and organization. For example, you can have a vehicle class with basic properties like speed, and a car class that extends vehicle. The car class will inherit the speed property, but can also have additional features of its own. Inheritance helps with code reuse, as you don't need to rewrite the same logic in multiple places. It also makes your code more flexible and easier to maintain. In summary, inheritance allows subclasses to inherit properties and behavior from a superclass. It's a key part of writing clean, reusable code in Java. Make sure you understand this concept for your interview. Good luck.
If your Java program never runs out of memory, thank garbage collection. Let's dive into how it works. Garbage collection in Java is the process of automatically freeing memory that's no longer needed. So, how does it do this? In Java, objects are created on the heap, and the garbage collector looks for objects that are no longer reachable, meaning no part of your program is referencing them anymore. These unreachable objects are then marked for deletion. The garbage collector runs in the background and reclaims this memory, making sure your program has space to create new objects without causing memory leaks. There are different algorithms for garbage collection, like mark and sweep, where objects are marked if they are still in use, and unmarked objects are cleaned up. To sum it up, Java's garbage collector helps manage memory automatically, reducing the risk of memory leaks. Knowing how this works can give you an edge in your Java interviews. If you found this useful, hit the like button and don't forget to subscribe for more Java interview tips. See you in the next one. Stop stressing about Java interviews. Let's simplify interfaces and abstract classes. In Java, an interface is like a blueprint. It only contains method signatures, no method body. Think of it as telling you what to do, but not how to do it. But wait, there's more. Abstract classes, on the other hand, can have both abstract methods and fully implemented methods. They're like a middle ground between interfaces and regular classes. So what's the key difference? Interfaces provide total abstraction, no implementation in the methods. Abstract classes allow partial abstraction with both abstract and concrete methods. And here's a pro tip. A class can implement multiple interfaces but can only extend one abstract class. Thank Java's single inheritance model for that. To sum it up, use interfaces for complete abstraction and flexibility when you need multiple contracts. Use abstract classes for partial abstraction with shared logic. Got it? Now go nail those Java interview questions. Don't forget to like and subscribe for more interview prep tips. Want to crush that Java interview? Let's break down array list versus linked list. An array list is like a dynamic array that stores elements in a continuous block of memory. This means accessing elements is super fast because it uses indexing. On the flip side, a linked list uses a doubly linked list structure. Each element is a node with references to the previous and next nodes. This makes adding or removing elements in the middle a breeze. So how do they stack up? ArrayList is your go-to for lightning-fast random access thanks to indexing. Linked list shines when you need to frequently insert or delete elements, especially in the middle. But remember, linked list has slower access because it needs to traverse nodes. In short, choose ArrayList for speedy access and linked list for efficient insertions or deletions. Knowing when to use each is key to optimizing your code, and this question often pops up in interviews. Good luck. Ever wondered how to differentiate this in super in Java? These keywords might look similar, but they serve very different purposes. Let's break it down. In Java, the this keyword refers to the current object instance. You use this to access instance variables and methods of the current class, especially when there's a naming conflict. It's also used for calling other constructors within the same class. On the other hand, super is used to access members of the parent class. It lets you call a superclass's methods or access superclass variables directly. It's also used to call the parent class constructor, helpful for inheritance chains. So in short, this is all about the current class, while super focuses on the parent class. Knowing when to use each one is essential for managing inheritance and instance variables effectively. To recap, use this for the current instance and super for the parent class. Mastering these keywords is a must for cleaner, more readable Java code, and for impressing interviewers. Did this help clear up the confusion between this and super? Hit that like button and subscribe for more Java interview tips. Why do 70% of candidates struggle with Java exceptions in interviews? Let's break it down. In Java, exceptions are events that disrupt the normal flow of your program, but they fall into two main categories: checked exceptions and unchecked exceptions. Checked exceptions must be either caught or declared in your method. These are checked at compile time. For example, IO exception or skull exception are checked exceptions. If your code doesn't handle these, it won't even compile. Unchecked exceptions are not checked at compile time, meaning your program can still compile even if these exceptions are not caught or declared. These include runtime exception and its subclasses like null pointer exception or arithmetic exception. They occur during runtime and are usually due to programmer error like trying to divide by 0 or accessing a null object. To sum up, checked exceptions need to be handled at compile time while unchecked exceptions pop up during runtime. Understanding this distinction will help you write more robust Java code and impress in your interview. Ready to take your Java interview prep to the next level? Like, subscribe, and hit the notification bell for more Java tips.
Let's talk about Java's secret weapon for data management, the Java Collections Framework. The Java Collections Framework, or JCF, is a toolkit for storing, retrieving, and manipulating collections of objects in Java. It's like having a Swiss Army knife for data structures. Here's a quick overview of the main components. List ordered collections that allow duplicates, like ArrayList and LinkedList. Set unordered collections that don't allow duplicates, such as HashSet and TreeSet. Map, a key value pair structure for fast data retrieval, with implementations like HashMap and TreeMap. The framework provides essential methods, like sorting and searching, making it powerful and flexible. It's foundational for Java coding and is almost guaranteed to come up in interviews. Found this useful? Hit like and subscribe for more Java interview insights.
If you don't like memorizing algorithms but still want to ace Java interviews, then understanding HashMap is your key. At a high level, HashMap in Java uses key value pairs to store data. It relies on hashing for efficient retrieval, insertion, and deletion. Here's the scoop. When you add a key value pair, Java generates a hash code for the key. This code determines where in the internal array or bucket the entry goes. Now, if two keys hash to the same bucket, that's a hash collision. They're stored in a linked list or sometimes a balanced tree for efficiency. Retrieving data, HashMap first hashes the key to find the right bucket, then checks each entry to find the match. With constant time performance for most operations, HashMap is fast, but understanding hashing and collision handling is key to avoiding pitfalls. Knowing these internals can set you apart in an interview. So next time you use HashMap, remember what's happening beneath the surface. Found this helpful? Like and subscribe for more interview-focused Java videos. If you're a Java developer, mastering multi-threading is a must. Let's dive in. Multi-threading runs multiple threads simultaneously, allowing tasks to happen in parallel. Concurrency handles multiple tasks at once by managing these threads. Key for building efficient, responsive apps. Use classes like Thread or Runnable to achieve multi-threading in Java. Create threads by extending thread class or implementing Runnable interface. Concurrency comes with challenges. Shared resources can lead to data inconsistency. Thread safety ensures a resource is used by one thread at a time, preventing race conditions. Synchronization locks resources, allowing one thread access at a time. Atomic classes like Atomic Integer offer atomic operations, avoiding race conditions. To sum up, multi-threading boosts performance, but thread safety is crucial to avoid data conflicts. Master these concepts and you'll ace your Java interviews. Happy coding!
If your Java code looks like a tangled web, you're in for a treat. Let's untangle strings, string builder, and string buffer. In Java, these three tools help you manage text, each in its unique way. String, think of string like a stone tablet. Once written, it can't be changed. This is great for text that stays the same, but not so much for frequent updates. String builder. Now, string builder is more like a dry erase board. You can add, erase, and rewrite without creating new boards. It's speedy but not thread safe, so use it when only one person is writing. String buffer. Finally, string buffer is like a shared Google Doc, editable and safe for multiple users at once. It's slower due to synchronization, but perfect for multi-threaded tasks. Example. Imagine you're writing a book. Using string means reprinting the whole book for every edit. String Builder or String Buffer lets you edit on the fly, saving paper and time. Knowing when to use each, String for fixed text, String Builder for single-threaded changes, and String Buffer for safe, multi-threaded edits, will help you optimize code and ace your interview.
Why do 80% of Java developers prefer streams? Let's unlock the mystery. So, what are Java streams? They're part of the java.util.stream package and offer a sleek way to process collections in a functional style. Imagine a stream as a flowing sequence of elements, transforming data as it moves along. Unlike collections, streams don't store data, they just handle it on the fly. Here's the magic formula. Streams work in 3 stages. First, the source, your data like a collection or an array. Next, intermediate operations, transformations like filter, map, or sorted. Finally, terminal operations. These produce results like collect, for each, or reduce. Let's bring this to life. Got a list of numbers and need the even ones squared? Use filter to pick even numbers, map to square them, and collect to gather the results. Easy, right? Streams shine with large data sets, supporting parallel processing for top-notch performance. Mastering streams can make your Java code cleaner and faster, a must-have skill for coding and interviews. Was this helpful? Like and subscribe for more Java insights to boost your interview prep.
In a Java interview, understanding synchronized could be your ticket to showing off solid concurrency skills. Let's break it down. In Java, the synchronized keyword is all about thread safety. Here's how it works. Synchronized controls access to code blocks or methods, allowing only one thread to enter at a time. This is crucial for avoiding data inconsistency in multi-threaded environments. Synchronized methods. When you mark a method as synchronized, it locks the entire method. This ensures exclusive access but can affect performance if overused. Synchronized blocks. For more efficiency, you can synchronize just part of a method. This way, only the critical code section is locked, letting other parts run concurrently. Interviewers ask about synchronized to see if you know how to handle concurrency risks, like data corruption. Understanding when and where to use it shows you know how to write safe, multi-threaded code. Mastering synchronized is key to showing off your Java concurrency skills in interviews. Good luck! Want to make your Java code cleaner and more efficient? Lambda expressions are here to save the day. Lambda expressions bring functional programming into Java, allowing for cleaner, more efficient code. They're a game changer for your coding interviews. So what are they? Simply put, Lambda expressions let you write short, single-method expressions, perfect for simplifying code, especially when dealing with collections or passing behavior as parameters. Here's the syntax parameters. Expression or code block. This lets you define functions on the go. Lambdas work with functional interfaces like runnable, comparator, or custom single-method interfaces. They cut down on boilerplate code, replacing bulky anonymous classes. For example, to sort a list of names in reverse order, use a lambda like this. It's that simple and clean. Lambdas make Java more flexible and improve readability, crucial for coding efficiency and nailing your interview. Mastering Lambda expressions can simplify your Java code and is a valuable skill for coding interviews. If this helped you understand Lambdas better, hit like and subscribe for more Java insights.
If you're a programming student, you need to know this. How does Java save and restore objects? Let's dive into serialization and deserialization. In Java, serialization is the process of converting an object into a byte stream, making it easy to save to a file or send over a network. This is especially useful for storing object states and sharing data between applications. How it works. By implementing the serializable interface, an object becomes ready for serialization. The object output stream class is used to write the object to a file or transfer it. Deserialization, on the other hand, is the reverse process. It reconstructs the object from the byte stream, restoring its original state when it's used. Serialization and deserialization are crucial when you need to save data for later use or transfer objects across systems, like in networked applications. Quick tip, not all fields need to be serialized. Use the transient keyword to skip fields that don't need to be saved. Mastering these concepts is key for managing object persistence in Java interviews. Try it out.
Want to impress your interviewers with clean code? Let's dive into Try with Resources. In Java, Try with Resources simplifies resource management by automatically closing resources, like files or streams, after use. Here's how it works, what it does. This statement opens resources within the try parentheses and automatically closes them when done, so you don't need a finally block to manually close them. This prevents resource leaks, a big advantage in interviews and real-world coding. How to use it? Declare resources in the try block, like this try. Resource type resource equals new resource type. The resource must implement the auto-closable interface to be closed automatically. Why it's useful? It ensures efficient memory use, makes code cleaner, and shows interviewers you know how to manage resources properly. Mastering Try with Resources can set you apart in interviews. Try it out.
Stressed about Java interviews? Let's crack comparable and comparator wide open. In Java, comparable and comparator are your go-to tools for custom sorting, but they aren't twins. Think of them as siblings with different quirks. Comparable is like the class's built-in sorting method. You implement it within the class using the compare-to method. Imagine an employee class sorting by employee ID. Simple, right? Now let's chat about comparator. This one's your versatile friend. You define it outside the class using the compare method. Need to sort employee objects by name or salary? Comparator's got you covered without touching the original class, so when should you use each? Go for comparable when there's a single natural order you stick with. Use comparator when you need that sorting flexibility. Multiple ways without altering the class itself. Mastering these differences gives you a solid grip on sorting logic. A must-have skill for Java interviews. Now go ace that interview. Curious about how Java gets your code up and running? Let's unravel the mystery of the class loader. In Java, the class loader is like a backstage crew silently loading classes into memory to make your program work. It's part of the Java runtime environment and handles the bytecode files, those .class files you compile. There are three main types of class loaders. First, the Bootstrap class loader. Think of it as the VIP loader. It handles core Java classes like java.lang. Next, the extension class loader. This one deals with Java extensions or optional packages. And finally, the application class loader. It's the one loading the classes you write. These loaders work in a parent-child hierarchy. When loading a class, each class loader first checks with its parent. If the parent can't find it, only then does it try to load the class itself. Understanding class loader helps you grasp memory management and runtime behavior in Java, a must-know for any serious Java developer. So next time you run your code, remember the unsung hero, the class loader.
I'm sure you've heard the news, mastering Java is a must for any aspiring developer. But what about those tricky keywords, volatile and transient? First up, let's tackle volatile. The volatile keyword in Java is used with variables that multiple threads access. When you mark a variable as volatile, you're telling Java to read it directly from main memory, not from a thread's local cache. This keeps the variable up to date and prevents inconsistencies in multi-threaded scenarios. Now, transient is a bit different. When you mark a variable as transient, it means it won't be serialized. This is perfect for data you don't want saved, like temporary or sensitive information. To recap, volatile ensures visibility in multi-threading, while transient skips serialization for variables. Mastering these helps you write safe and efficient code. Best of luck in your interviews.
Exposing the secret weapon in Java interviews. Am I the only one that didn't know how powerful reflection can be? Let's dive in. Reflection in Java lets you inspect and interact with classes, methods, and fields at runtime. Think of it as a toolkit to access private and public members of a class, even if you don't know the class structure beforehand. This is super handy in frameworks and libraries that rely on dynamic behavior, like dependency injection. With reflection, you can create objects, invoke methods, and modify fields on the fly. But remember, use it wisely. It can affect performance and security if not handled right. So, what's the takeaway? Reflection is your go-to for dynamic Java applications, but keep it efficient and secure. Nail this skill and you'll be unstoppable in your interviews. Happy coding, everyone!
Why do 90% of Java developers rely on annotations? Discover how they can make your code cleaner and your interviews smoother. Java annotations are like little sticky notes for your code. They don't change how your program runs, but they give important instructions to the compiler or runtime. Take it override, for example. It tells the compiler that a method is meant to override a method in a superclass. Handy, right? Then there's at deprecated. This one marks code that shouldn't be used anymore. It's like a polite way of saying, hey, there's a better way to do this. Frameworks like Spring and Hibernate love annotations. They replace those bulky XML configurations, making your code cleaner and easier to manage. So why should you care? Annotations boost readability, cut down on boilerplate code, and give frameworks powerful metadata. Mastering them can really set you apart in your next Java interview. Happy coding! What's something people don't know about Java? Immutability. It's a game changer for your code and interviews. Immutability in Java means creating objects that cannot change once they're made. Think of it like a stone sculpture. Once carved, it stays the same forever. A classic example is the string class in Java. You create it, and it's set in stone, no changes allowed. So how do you create your own immutable objects? Step 1. Declare your class as final. This prevents any subclass from altering its behavior. Step 2. Make all fields private and final. Private means no direct access, and final means no changes. Step 3. Skip the setters. Provide getters but return deep copies if the field is mutable. Step 4. Initialize everything through a constructor. No funny business after creation. Why is this important? Immutability is key for thread-safe programming and is a huge asset in caching and multi-threading. Master this and you'll shine in your Java interviews. So, ready to rock that interview? Go be immutable. Java interviews can be tough, but understanding deep and shallow copy can give you a leg up. So, what's the deal with shallow copy and deep copy? Picture this. A shallow copy is like photocopying a document. You get a new sheet, but the content is still linked to the original. In Java, using object.clone gives you a shallow copy. This means if you change a mutable field in the copy, it changes in the original too. Now, deep copy is like rewriting the document by hand. You get a new sheet with completely independent content, no shared links. To achieve this in Java, you'll often need custom implementation. Think serialization or manual copying. In interviews, highlight that deep copy avoids shared references, making your code safer and bug-free. Shallow copy is quicker but risky with mutable objects. Remember, mastering these concepts not only impresses interviewers, but also helps you write better, more reliable code. So next time you're prepping, keep these tips in mind. Happy coding.
This is why you need to understand Java memory management. It's a game changer in every interview. Stack versus heap. Two memory areas every Java developer needs to know. Stack memory is where method calls and local variables hang out. It's super fast and auto-managed, like your program's short-term workspace. When a method finishes, its memory is cleared instantly. Heap memory is the home for objects and instance variables. Think of it as long-term storage. Java's garbage collector manages it, and the heap is shared across all threads in a program. Perfect for dynamic allocations, but yeah, it's slower than the stack. So when to use what? Stack for local, short-lived variables. Heap for complex objects and anything with a longer lifespan. Pro tip: mastering this helps you debug memory leaks and boost performance. Essential skills for any Java developer. Nail this and you'll ace that interview. Thanks for watching. Like, share, and subscribe for more bite-sized tech insights.
You need to watch this if you struggle with Java serialization. Today we're demystifying the transient keyword. When you serialize an object in Java, all its fields are saved to a byte stream. But what if there's a field you don't want to save? Like sensitive information or data that doesn't make sense to persist? That's where the transient keyword comes into play. Fields marked as transient are skipped during serialization. When the object is deserialized, these fields are reset to their default values. Null for objects, 0 for integers, and so on. Pro tip: use transient wisely to avoid serializing data that could lead to security risks or unnecessary overhead. This trick is not just a lifesaver in interviews but also in real-world projects. So next time you're working with Java serialization, remember the transient keyword. It's a small but powerful tool in your coding arsenal. Happy coding! Java developers, listen up. Want to ace your interviews? Master the volatile keyword. In multi-threaded programs, shared variables can cause issues. Without volatile, changes might not be visible to all threads. Volatile ensures visibility. It forces Java to read the variable from main memory. This guarantees all threads see the latest value. But volatile doesn't make operations thread-safe. Use synchronization for atomicity. In interviews, know the difference between volatile and synchronization. Volatile ensures visibility. Synchronization ensures both visibility and atomicity. Understanding volatile is key to Java concurrency, essential for high-performance multi-threaded apps. Remember volatile for your next interview. It could be your edge to success. Master volatile. Master your career. Why are there not more people talking about exception handling in Java? It could be your secret weapon in interviews. Okay, so picture this. You're coding away and bam, an error pops up. No worries. In Java, we call these unexpected events exceptions. They can be anything from dividing by 0 to accessing a null object. To handle them like a pro, we use the try-catch-finally structure. Here's the scoop. The try block is where you put your risky code, the stuff that might throw an exception. If an exception happens, it's caught in the catch block. This is where you handle the problem and make sure your program doesn't crash. And finally, the finally block. This guy runs no matter what, making it perfect for cleaning up resources like closing files or connections. So, remember, try where the action is. Catch your safety net. Finally, your reliable cleanup crew. Mastering exception handling isn't just about avoiding errors, it's about writing robust interview-winning code. You've got this.
Stop struggling with slow Java programs. Supercharge them with the fork join framework. So what's the fork join framework in Java? Imagine you've got a huge task. Instead of tackling it all at once, you break it down into smaller, manageable chunks. That's called fork. These chunks are processed in parallel, making the most out of your CPU cores. Once done, the results are combined back together. That's join. It's perfect for tasks like sorting or data processing. The magic happens with the fork join pool class. You divide a task into subtasks recursively, and the framework handles them in parallel. Remember, it's ideal for divide and conquer algorithms. If you're asked about it in an interview, just explain how it boosts performance with parallelism while simplifying complex tasks. Master this framework and you'll definitely stand out as a Java pro in interviews. So, ready to fork and join your way to success?
I bet you didn't know mastering the Executor framework could boost your Java game. Let's dive in. The Executor framework takes the headache out of thread management. Instead of juggling threads manually, you just submit tasks, and the framework handles the rest. It offers different thread pools like Fixed Thread Pool and Cached Thread Pool. These thread pools optimize performance based on your app's needs. No more messy code or scalability issues, just clean, maintainable solutions. Acing Java interviews is all about showing you can write efficient, scalable code, and mastering the Executor framework does just that. It's your ticket to better concurrency skills and impressing those interviewers. So, dive into the Executor framework today and take your Java multi-threading to the next level. Good luck. If your Java threads are snoozing, they might be sleeping. But if they're waiting for a signal, it's wait time. Hey learners, let's clear up a common confusion. What's the difference between wait and sleep in Java? Picture this. Sleep is like setting an alarm for your thread. It's a method from the thread class that pauses the current thread for a set time. Think of it as a power nap. Your thread sleeps for a bit and then wakes up, still holding on to its lock. Now, imagine wait as a meeting room. It's a method from the object class used in synchronized blocks or methods. Your thread waits there until another thread sends a notification with notify or notify all. Unlike sleep, wait releases the lock, letting other threads use the resource. So, the key difference? Sleep doesn't release the lock, while wait does. Understanding these can boost your multi-threading skills and wow your interviewers. Comment below if you've used wait or sleep in your projects, and don't forget to subscribe for more Java interview prep.
Java warriors want to crush those interview questions on multi-threading? Today we're diving into thread pools in Java. Imagine handling multiple tasks without creating a new thread each time. Sounds efficient, right? That's where thread pools come in. Using the Executor framework, you can create different types of thread pools: Fixed Thread Pool, Cached Thread Pool, and Scheduled Thread Pool. Here's the scoop. Fixed Thread Pool is perfect when you need to manage a steady number of tasks concurrently. Great for maintaining control. Cached Thread Pool shines for short-lived, frequent tasks. It dynamically adjusts the number of threads, making it super flexible. And Scheduled Thread Pool. Ideal for tasks that need to run at regular intervals, thread pools optimize resource usage and cut down on the overhead of creating and destroying threads. They're a critical concept for both interview prep and real-world application. So get familiar with them and boost your Java skills. That's it for today. Hit that like button and subscribe for more Java tips.
Hey, Java developers! Ready to master thread safety? Let's talk synchronization. Synchronization in Java is the secret to thread-safe coding. Imagine a traffic signal controlling the flow of cars. Synchronization works the same way, but for threads, stopping them from colliding when they access shared resources. Here's how it works. Use a synchronized block to control access to specific parts of your code. Think of it as putting up a "Do Not Disturb" sign. Only one thread can enter the critical section at a time. Why use it? Sometimes you only need to lock a small part of your code instead of an entire method. This minimizes the synchronization overhead, boosting performance. It's that simple. Mastering synchronization keeps your multi-threaded applications safe and efficient. So remember, learn it, ace it, and nail those interviews. Java synchronization, your key to thread-safe code. Happy coding!
Are you anxious about nailing your Java interview? Let's clear up the basics of runnable versus callable. In the Java world, threads are like supercharged workers, and you have two ways to define their tasks: runnable and callable. First up, runnable. It's the classic way to define a job for a thread. With the run method, you don't get a result and it won't throw checked exceptions. Think of it as the go-to for simple tasks, like printing messages or updating UI components. Now, let's talk callable. This one's a bit more advanced. The call method returns a result and can throw checked exceptions. Perfect for complex tasks, like fetching data from a database or calculating something tricky. So if you need results or exception handling, callable is your best friend. For simpler jobs, runnable works just fine. Know the difference and choose wisely. Good luck with your interview prep. Catch you next time.
Are you tired of dealing with thread synchronization headaches? It's time to meet Reentrant Lock. Reentrant Lock gives you more control over thread synchronization than the classic synchronized block. Here's why it's a game changer. First up, try locking. This nifty feature lets you attempt to acquire a lock without getting stuck forever. Super useful, right? Next, fairness setting. It ensures locks are granted in a fair first-come, first-served order. No more thread favoritism, and don't forget lock interruptibility. This allows threads waiting for a lock to be interrupted, keeping your app responsive. But hey, with great power comes great responsibility. Remember to explicitly lock and unlock. Always call lock.unlock in a finally block to dodge those pesky deadlocks. Reentrant Lock shines in complex threading scenarios and highly concurrent applications. Want to dive deeper? Hit that play button and stay ahead of the curve. I'm sure you've heard the news. Java's Future lets your code multitask like a master chef in the kitchen. In Java concurrency, Future is your go-to for handling async tasks. Imagine you submit a task to an executor. It hands you a future object. Consider it a promise for a result that'll come later. While the task does its thing in the background, your main thread is free to tackle other operations. Need the result? Just call the get method. Though heads up, this blocks until the task is done. You can also peek at progress with is done, or pull the plug with cancel. Think of it like a food delivery app, calculating multiple routes all at once. With Future, you juggle these tasks seamlessly, keeping your app snappy and responsive. Mastering Future is a game changer for scalable Java apps and a hot topic in interviews. Ready to level up your Java concurrency skills? Let's do this. HashMap versus Hashtable. Do you know which one to choose? This one question can make or break your Java interview. Both store data as key value pairs, but they differ significantly. Thread safety. Hashtable is synchronized and thread safe. HashMap is not synchronized and performs faster in single-threaded applications. Null keys and values. HashMap allows one null key and multiple null values, while Hashtable does not allow null keys or values. Performance. HashMap generally performs better because it's not synchronized. Legacy versus. Modern Hashtable is a legacy class replaced by concurrent HashMap for thread-safe operations. HashMap is part of the modern collections framework. Imagine you're building a web app. Use HashMap for single-threaded operations like storing user preferences. For multi-threaded environments, opt for concurrent HashMap instead of Hashtable. Understanding these differences helps you write optimized and interview-ready Java code.
Ready to boost your Java interview game with a pro tip? Let's dive into weak references. In Java, weak references are a special type of reference that allows the garbage collector to reclaim the object even if it's still referenced. But why are weak references important? Imagine you're caching data, keeping it handy for quick access, but you don't want it hogging memory when it's no longer needed. Weak references ensure that unused objects can be cleaned up, avoiding memory leaks. Key interview points, what are they? Weak references don't stop an object from being garbage collected. Where are they used? They're commonly used in caches, maps, and frameworks where memory efficiency is crucial. How to explain in an interview. Highlight their role in memory optimization and compare them to strong references for clarity. Closing line. Understanding weak references isn't just about theory. It's about demonstrating your knowledge of efficient memory management in interviews. Make sure you've got this in your Java toolbox.
If you don't like your Java program freezing but still want to use threads, then let's fix deadlocks together. Deadlock occurs when two or more threads are stuck waiting for each other to release resources, creating an infinite loop of waiting. It's a common challenge in multi-threaded applications. So, how do we handle deadlocks? First, avoid nested locks. Keep the locking sequence consistent. For instance, always acquire lock A before lock B in all threads. This helps prevent circular waiting. Next, use try-lock. The try-lock method in the reentrant lock class lets threads back off if a lock isn't available, reducing the chances of deadlock. Also, take advantage of deadlock detection tools. Tools like Visual VM can help detect and analyze deadlocks in your code, making them easier to fix. Finally, limit locking scope. Use synchronized blocks only where absolutely necessary to minimize the risk of deadlocks. Understanding and preventing deadlocks is key for any developer working with Java concurrency. Nail this, and you'll be one step closer to acing that interview.
Sorting collections in Java can seem complex, especially with large data sets or intricate criteria, but the comparable interface can simplify it all. Let's uncover the magic behind the comparable interface. In Java, the comparable interface is like a sorting blueprint. It defines the natural order of objects in a collection. Think about sorting a list of students by their marks or names. With comparable, you can tell Java how to compare these objects. It contains a single method, compare_to. This method compares the current object with another, determining their order. It returns a negative, 0, or positive value. This return value dictates the order of objects, often used with collections like treeset or treemap, or when calling collections.sort. Implementing it ensures consistent sorting logic. Mastering comparable enhances your understanding of object-oriented principles. This knowledge is a significant advantage in job interviews. Want to dive deeper into sorting? Explore advanced techniques and algorithms. Let us know in the comments if you have any questions or topics you'd like us to cover next. If your Java interview is coming up and memory management sounds scary, you're in luck. Let's break it down. All right, let's dive in. First up, stack memory. This is where your local variables and method calls go. It's like organized storage for temporary data. Think loop counters or method parameters. Super fast, automatically managed, and operates on a last-in, first-out basis. Quick and efficient. Now onto heap memory. This is used for dynamic memory allocation. Imagine objects and instance variables, stuff that needs more space and flexibility. It's slower and managed by the garbage collector. So what's the key difference? The stack is for short-term, quick access data, while the heap handles larger long-term storage. Remember, use the stack for local variables and method calls, and the heap for objects and their references. Got it? Now go ace that Java interview.
I'm sure you've heard the news, Java's garbage collector isn't always a superhero. Let's talk memory leaks. While Java's garbage collector is powerful, it's not foolproof. Here are some common causes of memory leaks in Java unclosed resources. Forgetting to close files, streams, or database connections? That's a ticket to Memory Leak City. Always use try with resources for cleanup. Static references. Static variables can cling to objects for the entire application lifecycle, even if those objects are no longer needed. Inner classes. Non-static inner classes hold an implicit reference to the outer class. This can prevent the outer class from being garbage collected. Listeners or callbacks, make sure to unregister them. If you don't, they can keep objects alive longer than required. Collections with unused objects. Adding objects to maps or lists and forgetting to remove them can cause leaks. Manage resources properly, avoid unnecessary static references, and regularly monitor memory usage with profiling tools. Don't let memory leaks slow you down in coding or interviews. Follow DevDude for more Java interview prep tips. I'm sure you've heard the news, generics are a game changer in Java, but why? Let's break it down. Generics in Java provide a way to write flexible and type-safe code. Here's how they work and why you should use them. 1. What are generics? Generics allow you to define classes, interfaces, and methods that operate on types specified when you use them. For example, list =new ArrayList. 2 advantages of generics. Type safety. Generics prevent runtime errors by catching type mismatches at compile time. Code reusability. You can write a single method or class to handle multiple data types without duplicating code. Eliminates type casting. No more explicit casting, as generics maintain type information for you. 3. When to use generics. Collections like list, set, or map. Utility methods such as swapping elements or finding maximum values. Generics make your code cleaner, safer, and more efficient, perfect for interviews and real-world applications. Ending master generics and stand out in your Java interviews. Follow DevDude for more Java tips. Ever wondered what happens when Java cleans up memory? Meet the finalize method. It might just surprise you. The finalize method in Java is part of the garbage collection process, but here's the catch. It's rarely used today. When an object is no longer in use, Java's garbage collector is supposed to reclaim its memory. Before doing so, it calls the finalize method, giving the object a chance to clean up resources like closing file streams or network connections. Sounds great, right? But in reality, relying on Finalize is risky. Why? Because there's no guarantee when, or even if, the garbage collector will run. In modern Java, alternatives like try with resources or explicit resource management are preferred for better reliability. Pro tip: while Finalize is a legacy feature, interviewers may ask about it, so knowing its purpose and limitations is crucial. Show them you understand modern alternatives and you'll stand out. Ever thought Java 8's method references might just be the shortcut you needed? Well, you're in for a treat. Method references in Java 8 are a simplified way to call methods using the operator. This feature can streamline your code. Instead of writing a full Lambda expression, you can directly reference methods to improve readability. For example, imagine a list of names. Instead of a Lambda like names.forEach open parenthesis name arrow system.out.println open parenthesis name close parenthesis semicolon, you can write names.forEach open parenthesis system.out double colon println close parenthesis semicolon. See how much simpler that is? Clean, right? There are 4 types of method references: static methods, class name double colon method name, instance methods of a specific object, instance double colon method name, instance methods of an arbitrary object, class name double colon method name, constructor references, class name double colon new. These make your code concise, reusable, and elegant. It's an essential tool for modern Java developers. Start using method references today and see the difference it makes in your coding journey. Ever wondered what makes a process different from a thread? It's a must-know for any Java interview. In Java, a process refers to an independent program running in its own memory space. When you run a Java application, the JVM starts a process. On the other hand, a thread is a smaller unit of execution that runs inside a process. Multiple threads can exist within a single process, sharing the same memory and resources. Here's the key difference. Processes are isolated, while threads share memory, making communication easier but riskier. Threads are lightweight, so creating and managing threads is faster compared to processes. When one process terminates, it doesn't affect others. But if the main thread of a process ends, all threads in that process will terminate. So if you're working on multitasking within the same program, threads are the way to go. Processes ensure isolation, while threads enable faster communication. Understanding when to use each is crucial in Java interviews. Alright learners, big news! We've just wrapped up our Java interview prep series, covering all those critical Java concepts and top interview questions you need to crush your next interview. But wait, there's more. Before this, we completed our 50 Days of Java series, where we covered every fundamental Java concept with examples and code snippets to give you a solid foundation. And guess what? The combined video for 50 Days of Java is already live. You'll find the direct link and playlist in the description and pinned comment below. Now for those who prefer easy access to everything in one place, we'll soon drop the combined full video of the Java Interview Prep Series too. Stay tuned for that. Got ideas for our next content? Thinking about data structures, algorithms, or something else? Let us know in the comments. And hey, we'd love your feedback. How was this series? What can we do better? Thanks for sticking with us, learners. Let's keep leveling up.